Hello, everyone, and thank you for attending today's webinar, Network Densification, Solving Small Cell Deployment Challenges, presented by Microlab. I'm Kendra Chamberlain, contributor to Fierce Wireless, and I'll be moderating this webinar. Our speaker today is Luke Ghetto, Director of Product Management at Microlab. You can read his full bio on the right side of your window. Just a few technical notes before we begin. If you'd like to download the slide deck, please click the Resources List button at the bottom of your screen. The webcast is being streamed through your computer, so there is no dial-in number. For the best audio quality, please make sure your volume is up. You can find additional answers to some common technical issues located in the Help button at the bottom of your screen. This webinar is being recorded and will be available on demand within 24 hours after the event. We will follow the presentation with a Q&A session. Please submit your questions using the Q&A button on the left side of your screen. Okay, now let's begin. Luke, please go ahead.
Thank you, Kendra. Hello, everyone. Thank you for joining us today. Below is the agenda for this presentation. We'll start with a brief introduction to Microlab. We'll talk about the definition of a small cell as we have defined it for the purpose of this webinar. Compare the technology options for small cell deployments. We'll cover details on geographical location. We'll talk about the design requirements. And finally, we'll review some of the Microlab solutions to the challenges of small cell deployments. Microlab designs and manufactures high-performance RF components, integrated systems, and network time synchronization solutions. Our products are used in commercial wireless, public safety, and military applications around the world. Our mission is to provide our customers with products that deliver superior performance time after time. At Microlab, our commitment to performance, quality, and exceptional reliability with timely delivery is a key ingredient in establishing and maintaining successful customer relationships. Microlab provides passive RF and microwave components with over 1,000 standard products available from as quickly as next-day delivery. We constantly release new products based on market demand, and we work closely with customers on their specific needs. Whether it is installed in a small cell, on a train, or in a building. If we do not have a standard product to cover your needs, we offer customized solutions to optimize size and performance based on unique customer requirements. Finally, we offer advanced network time synchronization products for CRAN, DAS, and small cells. Here we can see some small cell market data provided by ABI Research. ABI Research provides strategic guidance for visionaries needing market foresight on the most compelling transformative technologies. From this data, by 2020, the combined units shipped per year is almost 1.6 million. You double that in total shipments in 2020 when you include APAC, which was left off the chart because it would dominate the graphic. Below the chart, you can see some more quotes on the future growth of small cells from other research firms. Besides these analyst predictions, Microlab has seen the growth firsthand. By percentage, most of our new products are designed for implementation in small cells. Now we have a quick poll for the audience. The question is, what is a small cell for you or your company? I'll give everyone a few moments to answer that question before I advance. All right, hopefully everyone has answered, so I'll move ahead to the responses. Okay. Pretty interesting. Nobody answered product or technology, while the miniature macro site was a large percentage, and all of the above was the most. And then we got a few people who are hoping to learn something from this webinar about what the definition is. There is no right answer to that question, as it depends on who you are talking to and in what context. It is true that there are small cell products, but the definitions can vary widely depending who you ask. There are also many different technologies that can be defined as a small cell or part of a small cell. What we are going to focus on in this webinar is the small cell as a field deployment site. All deployment pictures are provided by Crown Castle International Corporation, who owns, operates, and leases more than 40,000 cell towers and approximately 60,000 miles of fiber supporting small cells and fiber solutions across every major U.S. market. You may or may not agree that this is the definition of a small cell, but since this webinar is about deployment challenges, we'll go with that definition for now. So congratulations for those of you who chose the right answer. It seems like every day a new type of small cell deployment is announced. I'm sure you have seen many pictures in press releases, news articles, or elsewhere. This graphic shows some of the most common deployments. Each one comes with its own advantages, disadvantages, and challenges. When you need to add coverage or capacity with a small cell, you need to review the requirements of each. In many locations, you may have limited options, so your decision may be made for you. In others, you will need to decide which is the best option based on your needs at the site, whether that is one location or a citywide deployment. For indoor deployments of small cells, you have two options. The first is to deploy small cells everywhere coverage is needed, as shown here on the left. On the right, you can see where the small cells would need to be deployed on a floor of that building. The simulation image provided by DASCAD from Tetros Systems, a 5G-ready unified solution to design and plan macro, small cells, DAS, and Wi-Fi in one platform. The benefit of this deployment is capacity. The disadvantage is that it is most likely well over capacity requirements to meet the coverage needs due to things like stairwells, elevator shafts, or other impediments to RF signals that require a higher number of radio nodes. Additionally, a small cell would be required for each carrier, which means completely parallel infrastructure. So in this deployment, there is a high CapEx cost, but it can be easier to troubleshoot as you have intelligence all the way to the end node. Option number 2 is a distributed RAN or DRAN deployment, where the in-building coverage requirement is met by distributing the small cell signal using a small passive DAS hanging off it. This meets the capacity and the coverage requirements at a lower capital cost. DRAN is also better for neutral host deployments. The small cell box shown here can be in an IDF closet with several carriers and multiple bands per carrier, where the signals are combined into a shared passive distribution system. We'll talk more about neutral host shortly. To describe your equipment options, I diverge from my previous mandate on the definition of a small cell. So sorry, but not sorry. Moving on. A small cell is an integrated BBU and radio. The positives of a small cell is that it's smaller and cheaper to deploy and maintain. The backhaul connection can be long distance. The negatives of a small cell are the limited capacity. They are typically lower output power, which means less coverage, and they need GPS or PTP synchronization on site. CRAN, also known as centralized RAN, separates the BBU and the radio and adds a layer of fiber referred to as front haul between the devices. The benefits include full macro performance at the radio. They are typically higher power, which means more coverage, and they can be synchronized remotely at the BBU unit. The drawbacks are that front haul has limited distance, and they can be expensive to deploy. There are two types of deployments. First is carrier-led, where the network operator acquires, constructs, and maintains the site themselves. Typically, there are less radios, smaller antennas, and lower power supply required. This means a lower OpEx for the carrier. But more individual sites are required in a city, so each carrier must go through their own site approval. This can mean a higher CapEx investment from the carriers. In a neutral host or a shared site, the carriers lease the site from a neutral host provider that is acquired, constructed, and maintains the site. This means that there are less individual small cell sites, which is more pleasing to townships, municipal governments, and citizens. If you look at these images, you can see there are real drawbacks to trying to get multiple carriers to come in to cover a single intersection without sharing infrastructure. The drawbacks to neutral host is that you may need to combine many radios, which can require bigger antennas and more power. Since the carriers are renting, there can be lower or even no CapEx required from the carrier, but there's a higher OpEx cost. Initially, a small cell can be deployed for only a single carrier by neutral host companies, but later, other carriers can be added on to the site. Adoption of the multi-tenant small cells is happening at a much faster rate than it did for macro towers. Is your small cell site intended to fill in coverage gaps or increase capacity via densification? I mention this difference only to make sure we are completely covering the topic thoroughly. But in reality, the majority of outdoor small cell deployments are capacity adds. Dense networks or ultra-dense networks are essential for 5G. Practically everywhere you go in the U.S. has cellular coverage, so today's customers are more focused on how fast they can Insta-Google tweet face. Indoor deployments, however, can still require coverage at a minimum, but typically indoor coverage-only solutions consist of repeaters. If the money is going to be spent, it is worthwhile to make sure the solution has the capacity the users want too. Now, it is not entirely cut and dry on which parameters are exactly for coverage or capacity, but there are a few generalizations we can make that I will define in the next slides. For coverage, the lower the frequency, the further the signal travels in open air or through objects. The higher the frequency, the lower the distance and penetration. As you mix bands at a site, you need to consider how the different bands will geometrically differ in terms of coverage. RF power. As Tim the Toolman would say, it just needs more power. More power equals more distance. But if you want uniform coverage, you will need to adjust the power levels for radios in different bands. Without uniform coverage, the data rates at the center and edge of the cell could be drastically different. This can be achieved by attenuating the RF output of lower bands to match the high band coverage. But you are just wasting power to do so. Distance, of course, where you place the cell, can heavily dictate the area it covers. This can be impacted by the height of the deployment and environmental obstacles. Now for capacity, there are a few different options you can use to add higher levels of capacity to your small cell site. In the digital domain, different LTE channels, whether they are in the same band or different bands, can be combined or aggregated for a larger effective bandwidth to the end user. At Microlab, we are not seeing many customers deploy anything but multi-band sites using carrier aggregation. This necessitates more radios and more signal combining and splitting at each site. LTE-LAA, or License-Assisted Access, uses carrier aggregation but in unlicensed spectrum bands like CBRS at 3.5 GHz and Wi-Fi from 5 to 6 GHz. This year, we have seen customers designing in this feature in a much higher proportion. All the carriers have talked about using LAA to achieve 1 gigabit per second throughput. According to ABI research, 21% of in-building wireless equipment sold in 2022 will support shared and unlicensed spectrum. LAA adds another radio and possibly another antenna port. So it is not without cost despite the unlicensed spectrum. In addition, the 5 GHz Wi-Fi band is already pretty well used, and it will only get more congested over time. Over-reliance on this band can put your deployment at risk of falling short in the long term. CBRS still needs to be authorized by the FCC, and the spectrum sharing model is new. But that is not stopping carriers from ensuring future-proof deployments for this band. As a member of the CBRS Alliance, Microlab is optimistic that the rules will be finalized this year. MIMO improves spectral efficiency. We see 2x2 sites becoming the minimum, with more and more 4x4 sites being planned. In some cases, we see 4x4 in licensed bands enhanced with 2x2 in unlicensed bands. The thing to keep in mind here is that this can double the equipment required. If you have 2x2, you need 2 antennas. When you have 4x4, you need 4 antennas. Now consider when you use multiple bands for carrier aggregation and adding MIMO on top. The supporting equipment can add up fast. You may have heard of 8x8, 16x16, 64x64, or even higher orders of MIMO. These require further complexities like active beam steering in large antenna arrays, which further adds to the site cost and complexity. The definition of passive intermodulation, or PIM, is beyond the scope of this webinar. If you are unfamiliar with the concept, you can reference our website for white papers on the topic to learn what it is and the causes. LTE uses adaptive modulation schemes with higher data rates, the higher the quality of the RF channel. Any interference in the network degrades the RF channel quality and consequently capacity. PIM is a source of uplink interference, and it directly affects coverage and data throughput. Eliminating PIM is key to achieving maximum coverage and throughput at your site. Inter-site interference is also a challenge. At some point, the capacity benefit of densification starts to plateau, and then even decline. Each small cell adds more RF noise, so careful network planning is key. Here we can see some of the ingredients in a small cell recipe. From the bottom, fiber backhaul or front haul to the site, the power supply for the radios themselves, passive components to route and combine radio output signals for carrier aggregation and MIMO to the antenna. There is the antenna, of course. And there is GPS, which may be required by the radios for synchronization. And finally, the physical construction to make it all fit together mechanically, operate electrically, and look nice. One of the most talked about aspects of small cell deployments is local approval. Carriers and neutral host providers say site acquisition and backhaul are the top 2 deployment challenges. They are required to comply with the National Environmental Policy Act and the National Historic Preservation Act when designing and building small cells. Companies must complete an environmental analysis, and the document must be put on public notice for 1 month. Likewise, builders are required to consult with state historic preservation offices and with any tribal nations that have an impact on the site. Currently, small cells undergo the same review as for macro sites, despite the clear difference in scale. But starting July 2nd, new FCC rules go into effect to attempt to streamline the wireless infrastructure siting review process to facilitate the deployment of next-generation wireless facilities, which include small cells. In addition, 19 states have enacted laws specifically for small cells, with bills in other states pending. Unfortunately, the governor of California recently vetoed a bill like this, citing the value of local governments managing their own rights of way. Look at this beautiful example of a small cell. That's the kind of design that will get approved. Having previous design examples like this is a good way to move the process along, but you still need to be realistic. It can take 1 to 2 years to deploy a site. It just would not be a small cell webinar without a picture of a hideous deployment, so we can check that box now. The example on the right is why cities and states are hesitant to move fast. They have been burnt in the past by giving approval, and then the final product wildly differs from the proposal. You need to keep the local municipality involved, and you need to be patient. It is the government, after all. There are a battery of tests that are necessary before fully activating the site. It's critical that quality is ensured from the beginning of design, part selection, and installation to make sure these final steps go smoothly. Any type of failure could require a costly truck roll to the site to troubleshoot. And it can delay the start date, which can be a real impact to neutral host revenue. Microlab offers several products to address the challenges of small cell deployments that I talked about. Our multi-band combiners, like this BK747, are optimized for size and performance. The small form factor and IP67 design makes it ideal for locating in a small enclosure like a light pole. The various mounting options give small cell designers flexibility in their deployments. We also offer a broad line of products that cover from 600 megahertz all the way to 6 gigahertz for carrier aggregation, combining both licensed and unlicensed spectrum bands. Microlab has released an entire line of products designed for harsh environments around the coast, where the salty sea spray can degrade components' aesthetics and performance over time. These components are guaranteed to last. The Small Cell Carrier Conditioner, or SCC series, is a custom solution intended to combine the electrical, mechanical, and concealment requirements of a site into an easy-to-install element. By integrating the passive components, the technician only needs to connect cables from the radios to the bottom of the unit and the cables to the antenna from the top. The technician does not need to worry about fitting custom brackets or finding issues with PIM after installation, which could require multiple trips back to the shop. This reduces the operational time required to deploy a small cell, and those savings would be multiplied for a large deployment. By working closely with the customer in the design stage, we can make sure the final product is to their exact specifications and expectations. You can also see here that we accommodate for GPS synchronization requirements of the radios with our active GPS splitter products. The modular carrier conditioner, or MCC series, is a different approach intended for neutral host DRAN architectures. Instead of a completely custom design, this unit is manufactured for standard slide-in cards of passive components. It helps combine RAN radio heads for RF distribution in an easy-to-install form factor. It has been designed to provide up to 4 operator SISO configuration for 2 sectors, or 4 operators with 2x2 MIMO in 1 sector, or 2 operators with 4x4 MIMO in 1 sector, or other custom configurations in between. The benefit is that the plug-and-play chassis can be easily upgraded for future requirements, alleviating some of the unknowns and initial costs when the number of carriers joining or site upgrades are undefined. We have discussed the ingredients and requirements of a small cell. We have reviewed a smorgasbord of options that need to be considered when deploying a small cell site. We have discussed the pros and cons that each option has. I hope this information gives you the tools you need to make informed decisions when implementing your next small cell. Thank you for attending our webinar, and now I hand it back over to Kendra for the questions.
Okay, thank you, Luke. So now let's move on to the Q&A. There is still time to submit your questions using the Q&A button at the bottom of your screen. We have some great questions already, and we will try to get to as many as possible. Okay, Luke, before customers experience 5G type services from small cells?
Depending on your definition of what 5G really is, we think that, whether it's LTE advanced or 5G new radio, I think this year you're going to start to see much higher data rates with those 4x4 in the licensed bands and 2x2 in the unlicensed bands, getting the data rates pretty far up there into the gigabit per second range. So that's what some of the carriers are defining as 5G, and I think you'll start to see some of those benefits even this year. It won't be until next year that some of the new technologies are implemented, maybe like millimeter wave or fully deploying the new radio.
Okay, great, thank you. The next question. Does each carrier need their own dedicated fiber to a shared small cell site?
They do not. They can lease their fiber from a company, and they can also share that infrastructure at a neutral host site to have the benefit of only requiring 1 fiber to each site, whereas the challenge to lay 3 or 4 fibers to every single small cell site would be a real challenge. So there are other options.
Okay, thank you. Next question. What is the difference between DAS and DRAN for in-building wireless? In-building wireless, yes.
So for DAS and DRAN, DAS is a completely different type of installation where it's a total system install. I think the main difference can come down to where the carrier has intelligence about where their users are and what sort of capacity they're using. In a DAS, there's a demarcation point where the carrier radio plugs into that DAS. Then the DAS takes over the performance functionality throughout the building. In a DRAN, you're effectively installing your small cells much closer to the end user, the user equipment. So that capacity can be managed. The quality of service can be managed more directly by the carrier versus by the DAS. Typically, we've heard that DAS, especially active and digital DAS systems, are more expensive to deploy than DRAN solutions.
Okay. Okay, and next question, can operators share radios?
It's possible in technical terms. We don't really see that happening. There are multi-operator small cells, but we really have not heard of any large-scale deployments. Even the neutral host model, sometimes the carriers don't like to share infrastructure. When you talk about giving up control of the radio, that is something that needs to be at the highest quality level, and they want to make sure that radio is one of their approved products, and they have full control over that radio. So in general, in the U.S. market, we don't see them.
Okay. Next question. In your opinion, what would be the major challenges for using millimeter wave to provide backhaul to small cells?
The major challenge is just that, in general, millimeter wave requires line of sight. Now, if you have a string of small cells down a city street, you may be able to line up a millimeter wave system to, kind of daisy chain down that street to multiple small cells. But as soon as you talk about going around a corner, you lose that line of sight. So that's really the challenge, is that where your source is, you really need that line of sight, and in many urban situations, that just may not be possible. Suburban, it may be a little bit more easier to accommodate, but you have to also consider that there are things moving in these environments. If you've got a truck that pulls into a non-parking spot up on the sidewalk and delivers something and stays there for the whole day, that could block your signal. Those are the things that are can't be controlled for.
Okay, great, thank you. How much do you think channel reuse improves capacity in LTE deployments?
Yes. I think we'd have to take that one offline. I'm not really sure about the answer to that one.
Okay, we can move on. Okay, what about this? What is the height of a small cell tower?
That can vary. If we go back to the slide of my diagram, I mean, there are companies that deploy small cells in manholes, where effectively the manhole cover is the antenna. So that's a zero type height, and then you can see everything in between. You can see things on a lamppost, which may be 20 feet high, or a telephone pole, which could be 30 feet high, as well as what they call the smack rows, which is a site that it's just a little bit taller, but it's completely dedicated to RF distribution, and those can be up to, I think, even 75 feet high. It's, I think, after the 75 feet that we kind of see the difference, the demarcation point of what's a small cell and what's a macro.
Okay. And next question, why is GPS needed at small cell sites?
So in order to get your fast data rates for your phone, downloading those YouTube videos or whatever at 4K, you need to have your network synchronized. So all of the cells across the country need to be synchronized together in both phase and frequency. As the technology advances, we see the phase synchronization requirements move to be tighter and tighter. So the GPS is essentially a stratum 0 clock that can be referenced for phase and frequency alignment. So if at a small cell site, if you're deploying a specific type of radio, it may require a GPS input in order to be synchronized to the network. If it is not synchronized, it can be degraded down to a lower service quality, down to 3G, so your small cell site is no longer serving the capacity needs you want it.
Okay, great, thank you. Next question. As network densification implements 5G, which architecture will be more deployed, small cells or DAS?
I think we believe that small cells are just starting to take off, and we see DAS declining. There are a lot of people who have been saying DAS is dead for several years, if not a decade, but whereas the future promise of small cells back in 2010 was not what people anticipated or hoped for. However, we really see that the small cells are now starting to drive more deployments than DAS, at least from our vantage point. There is still a place for DAS, especially in large venues, but as the carriers start to push the deployment costs onto the building owners, the cost of DAS can be somewhat preventative. So the lower cost point of small cells or DRAN in building can be more attractive. And as we talk about, other technologies like CBRS coming in, where the radios are going to look more even like access points, I think this will further contribute to the decline of DAS.
Okay, great. Next question. Are you seeing LAA being deployed as 2x2 or 4x4?
In general, I think the LAA bands are 2x2 right now. 4x4 is what's being deployed on the licensed bands. So those are the LTE anchors. So the 2x2 in the LAA is kind of an add-on for more capacity.
Mm-hmm. Okay. Next question. How do you see the future of small cells in 5G network in terms of ratio to macro? So for example, is it 10 small cells to 1 macro, for example?
I don't specifically have an idea of what that ratio would be. I think it's going to be very high, though. We're seeing more and more small cell deployments come online. I mean, they're talking about cities with thousands of small cells, where you have a handful of towers in those same cities. In a 5G network, I mean, they're really talking about ultra-dense networks. So it's going to be a very high ratio.
Okay. Great. Next
just on that, I also think that small cells are also, for the in-building space, they're taking off as well. So, as you may have not heard in the news, there's something like 80% of all network traffic takes place indoors. So, they're not really deploying those macro base stations to feed a DAS anymore. If they are still doing DAS, they're feeding it with a small cell. Or they're just deploying small cells within the building.
Okay. Okay, and next question, will CBRS be deployed on a small cell or DAS?
Based on our conversations with the CBRS Alliance, it will definitely be deployed on a small cell. There are, specifications for a Category B device that's considered a small cell, which is RF power above 1 watt, located outside above 3 meters. It's possible you can distribute CBRS on a DAS. However, each antenna needs to report its location back to the spectrum controller. So I see this being a challenge for a DAS to register each remote radio as a unique transmitter. So it's not completely proven yet whether that's going to be feasible with the current architecture of CBRS.
Okay. Let's see, next question. What is the difference between multi-fire and neutral hosting?
Multi-fire, neutral hosting is a type of deployment, whereas multi-fire is a technology. Multi-fire is, a radio, an RF transmitting technology using TDD and listen before talk. They're kind of comparing apples and oranges. The multi-fire from Qualcomm is a new way that they're proposing to use TDD spectrum specifically in unlicensed bands. Neutral hosting can use both licensed and unlicensed bands, and technically multi-fire could be used in any of those bands if they're TDD. That would be up to the equipment vendor whether they support it or not.
Okay. Thank you. Next question. Okay, does it make sense to deploy low band 700 megahertz, for example, on a small cell? And if so, what would be a good use case scenario for that?
That's a good question. As I mentioned, when you have a low frequency like that, your signal is going to go a lot further than another signal at 2 gigahertz. And then if you talk about LAA at 6 gigahertz, it's going to go tremendously further than that. I can't specifically comment whether it makes sense. However, I think that a good use case scenario would be just in an area where there's not macro coverage. That may be an option where the coverage from a 700 megahertz deployment doesn't penetrate that street or location. It could be a suburban area, which a tower is just out of the cost question. If you do need that capacity by adding an additional band to your small cell, I think you're just going to have to attenuate a lot of that signal. Otherwise, it's really going to cause some havoc by having all these 700 megahertz sites closely located, especially when that signal can penetrate walls a lot further. So you may be overlaying not just on your macro deployments, but on your in-building deployments.
Okay, great. So, next question. Okay, here's another question about multi-fire. What is the difference between multi-fire and LAA?
So, the difference is the kind of the technical specs. Multi-fire can be used, I think, without an LTE anchor. You can just basically deploy an LTE-type signal in an unlicensed band. License-assisted access is enhancing the capacity of a licensed spectrum by using additional bandwidth in unlicensed spectrum. So it's still an LTE signal, or it could be a Wi-Fi signal. But the multi-fire is an LTE signal.
Okay. Okay, great. We have one final question. I'd like to remind the audience that we had a lot of great questions, and we will be getting back to everyone who submitted who we didn't get to after the webinar. Our last question is, what is the battery backup requirement for small cell?
We believe that it's about 48 hours as a backup requirement for a small cell. 428, sorry. Not 48.
Okay.
428.
Okay, great. Well, thank you so much, everyone, for attending this Fierce Markets webinar and for submitting so many great questions. And I'd like to thank our speaker, Luke, for participating and Microlab for presenting today's webinar. This webinar has been recorded. You will be able to access the recording within 24 hours using the same audience link that was sent to you earlier. Thank you again for joining, and we look forward to seeing you at future events.